Hi, 8th grade students, it's Mr. Alford, and this video is going to help you with homework number 6, which is Geometry Review Part 1. You should probably read the announcements. In assignment instructions, I'll explain a little bit. There is a document called Transformation Rules Cheat Sheet. Look at first page only. So that is talking about this PDF, and when you click on it, it opens up and this is a cheat sheet, some notes that we got early this spring semester. You can look at the other pages if you want, but I just said look at the first page only because all the other pages don't really help you. The first page really just summarizes everything you need to know about transformation. So that's why I just said look at first page only. Okay. I won't read this to you in this video. I would recommend just reading all of everything you see on the right side of this page, the whole thing. I will explain one thing just to make sure it makes sense. When you are doing rotations, we do, for rotation 90 degrees clockwise, we switch the coordinates and change the sign of the new y coordinate. Change the sign of the new y coordinate. And that on this side of the page right over here, you see rotation 90 degrees clockwise. Here's your x and your y. So you switch them, y and x. You take your new y value and you change the sign of it. That doesn't mean you turn it negative. That means if it's positive, you make it negative. And if it's negative, you make it positive. Rotation of 90 degrees counterclockwise, switch the coordinates and change the sign of the x coordinate, which is right here. So your x value and your y value. So you flip them. So you have your y, then your x. You take your new x value and you change the sign of it. And then rotation of 180 degrees, change the sign of both coordinates. So rotation 180 degrees, here's your x and your y. And you just change the sign of them. You don't switch them around. All you do is change the sign of them. That's all I will explain about this document. So this is your homework that you are supposed to do. Of course, this document will help, and I would strongly recommend that you read the right side of the first page of this document just to reacquaint yourself with how all the different transformations work. Let's see. I will help you with some of these problems. Problem 4. Let me actually show you the picture for problem 4. So problem 4, you've got this picture of a pool. 4.5 is talking about how deep the pool is, which is another way of saying how tall the pool is. So let me read it. It's the same thing right here. Nixie will be sitting on top of the dunk tank at her school's carnival fundraiser. She wants to find the volume of the tank so she can figure out how much water she will need to fill it. The tank is 4.5 feet deep, which is another way of saying it's 4.5 feet tall. The height is 4.5 feet, and has a circumference. This is the formula of circumference. It has a circumference of 31.4 feet. And I should probably say a little bit about that. That just means, so here's the formula for circumference. C equals 2 pi r. It's telling you the circumference, you can replace this C with 31.4 feet. What is the approximate volume of the tank? So the final question is really, what is the approximate volume of the tank? Use 3.14 for pi. Remember, the formula for the volume of a cylinder is this thing right here. And I just rewrote it down here. If it makes more sense for you to see it this way, maybe you want to pause the video and copy this formula. V equals pi times r squared times h. So your final goal is to find the volume. And so with this equation, you want to start replacing things here with some numbers. Like for example, pi, you know what number to replace that. And you're going to be stuck with trying to figure out what the radius is. And so that's when you are going to use this equation right here. (31.4), that's what it told us the circumference is, equals 2 pi r. So you can use this equation to find the radius. This equation you can manipulate to find the radius of your tank, and then from there go back to the volume formula, finish the volume to find the approximate volume of the tank, because that is what the question is asking. Find the approximate volume of the tank. That's all the help for that problem that I'll give. Problem 5. I'm just saying that it's giving you the formula for the volume of a cone, and I rewrote it here. Volume equals pi times r squared times h, all divided by 3. We've also seen it written this way in class. You can use either of these formulas. You'll get the same result. It doesn't matter which one you use. Maybe you want to pause the video and copy these formulas. Problem 7 is talking about the volume of a sphere, and I just rewrote for you the formula for a volume of a sphere. Maybe you want to pause the video and copy that. Problem 9 is a Pythagorean theorem problem. I'm really confident that you guys can handle this kind of thing. Just a quick reminder, the Pythagorean theorem is a squared plus b squared equals c squared. You can't just put any number you want into a or b or c. You've really got to think about what is your a and what is your b and what is your c in this problem. Drawing a picture is always really helpful. This is a picture of a triangle. It's a right triangle. We can only use the Pythagorean theorem with a right triangle. It's a right triangle because you can see this little green, these two little green lines that when you see that, that tells you that this triangle is a right triangle, that this angle of the triangle is 90 degrees. A is always one leg of the triangle, B is always the other leg of the triangle, C is always the hypotenuse. The hypotenuse is always opposite of our right angle. That's enough help for that problem. Here's another problem, I can't remember which one, that is talking about parallel lines. Just a quick reminder of what parallel lines are. So this line, if I want to make a parallel line of that, that would be something like this. These two lines are pointing in the exact same direction. Parallel lines mean that you have two lines pointing in the exact same direction. So this line is going kind of up like that. This line is going up like that. Okay. Here's another example. This line is totally horizontal, and this line is totally horizontal. Both lines are pointing in the same direction, just like that and like that, the exact same direction. So that's just a review of what parallel lines are. Problem 11. It's just a Pythagorean theorem problem. You know this because it's telling you you need to do something with the hypotenuse. That is, it's saying that this line on this graph is going to be the hypotenuse. Obviously, that means that you have part of your triangle. You should think about how you make the rest of the triangle, and then you're going to use that with the Pythagorean theorem. Don't just try and count how many squares this line goes through. That's not how you do this. You need to use the Pythagorean theorem. Problem 12. Okay, this is talking about, we've got two parallel lines. They're going in the same direction. Both of these lines are cut by a transversal line. Remember, whenever you have this kind of situation, you end up with these 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. These 8 angles, every 2 angles are either congruent to each other or supplementary to each other. Remember, congruent means equal size. Supplementary means the 2 angles add up to 180. So, for example, if I just pick any angle, all right, I'll pick angle 6. that angle is obviously acute. It's less than 90 degrees. So if I find any other acute angle in this figure, then it will be congruent to this angle 6. So, for example, angle 7 is acute. It's those two lines are smaller than a 90-degree angle. So, angle 6 and angle 7 are congruent. Meanwhile, angle 6 is acute, but angle 5 is obtuse. So, that means that they're not congruent to each other, which means that they are supplementary to each other. That means that they add up to 180. That's enough help for that problem. Okay, last little bit. This is kind of talking about transformations, and I just wanted to make this clear that we have 4 types of transformations. The first 3 types we learned are translation, reflection, and rotation. When we do any of these 3 transformations, the pre-image, that's the shape before the transformation, and the image is the shape after the transformation. So the shape before and the shape after the transformation are congruent. But when you do a dilation, and that's when, like, if you go to the eye doctor, they will dilate your pupil, which means that your pupil will go from like small to really big. Dilation means a change in size. The pre-image and the image are, when you do a dilation, only with the dilation, the pre-image and the image, your 2 shapes are not congruent. They're not the same size anymore, but they are similar. Just means, similar means, I mean, you know, you think about the word similar, it just means 2 triangles are similar. They look like the exact same. It's just that one is a bigger version of the other. That is enough help for this video. Good luck, guys. Email me or call me if you have questions.